approaches to knowledge representation. Um, so, what are the approaches of representing knowledge? We've seen the importance of this already. The first one is relational knowledge. Simplest way of storing facts, which uses the relational model. You heard about it maybe in database systems as well, people who are familiar with the computer science basic concepts. And each fact about a set of the object is set out systematically in columns. Okay. This approach of knowledge representation is famous, as I said, in the database systems. The relational model, based on the relationship between various entities. This has little opportunity for inference. You can't deduct new information out of that in general. Okay. So we need to do something else. In the diagram here, as you can see, various opportunities. On the left, in the first column, you have a player, and then the second column you have the weight, and on the third column you have the age. So player 1, weight 65, age 23. Player 2, weight 58, age 18. Player 3, weight 75, age 24. So this is basic relationship or representation that we're talking about. Another type which is very, very useful is the inheritable knowledge. Inheritable. Okay. The data is stored in the form of a hierarchy of classes. And the word inheritable or inheritance, that once again comes from the human, side of things. All classes are arranged in a generalized form in a hierarchical manner, right? In this approach, we apply the inheritance property like humans. So elements inherit values from other members of a class which are higher up in the hierarchy. So at the top you have a very general thing, let's say a human being, and then you have males, females, and so forth. So as you go deeper down, you realize that you're being very specific, and the things down in the hierarchy, okay, is actually inherited transfers from the things upstairs, in the hierarchy upwards. This approach contains, as I said, inheritable knowledge, which shows a relationship between what we call as an instance and a class of that instance called relation. And every individual, okay, can represent a collection of attributes and its values. So you inherit properties from your parents, okay, and then you have your own as well. So parents are up there, and then children, and then grandchildren, and so forth. So each of them will carry some part of their genes and inherit those properties, and then they will have their own as well. And in representation form, they are represented as boxes. And we use arrows to point out from relationship between objects. So the most common one is called an is a. Okay, a dog is a animal. Okay, a whale is a fish. And then when you're being very specific, you specify, you call it is an instance of. So instance of means that there could be multiple boys in a class. So you have boys in a class, and then you have Khalid, Tariq, Ahmed. They are instances of each of these. If you look at the diagram here, at the very top, as I said, is the adult male. Okay, and if you look deep down, we are given two different names, Peter and Ankit. Now, Peter is an instance of a cricketer. Okay, Ankit is an instance of a footballer. Right? These are specific people who are instances, or so to speak, copies of a cricketer as well as a footballer. Now, a cricketer is a player, and that's shown by that is a relationship. And as you can see, we have seen the two instances shown by the arrows, followed by, if you go up, it's called an is a. So a footballer is a player, a cricketer is a player, and a player, of course, is an adult male. So this is a representation of uh, inheritable knowledge. Another type is the inferential knowledge. Okay, approach used to derive more facts, inference, deduct, find out what does this mean. Okay, uh, typically represented in the form of logic, or otherwise as well. In fact, it guarantees correctness. Okay, so let's say there are two statements or sentences that Khalid is a man. Okay, Khalid is a man. This is a statement. And another statement, all men are mortal. So, given these two statements, okay, you can represent this in the form of logic as well. Okay, man bracket Khalid, man bracket Ahmed, for instance. Then, in logical form, you can say for every x, okay, where that man is x, means that x is a mortal, meaning for all values of men, okay, they're all mortal. For all men are mortal. So a very simple, small representation of what we mean uh, by the inference that we get out of this. Procedural knowledge, as I said before, it is like approach uses small programs and code. This is an SOP, how to do things, and it uses small programs and codes which describe how to do specific things and how to proceed. A recipe, okay, is a procedural knowledge. An algorithm, you're trying to prepare a curry. What do? Okay, you first take a few ingredients, okay, you heat them up, put some oil, maybe onions and so forth, and then you keep on doing it, and there you are, you have your dish prepared. So that's a procedural knowledge. That's a recipe. Uh, in this approach, we also have what something called if-then rules as well. If-then rules, uh, they are two very interesting. In this case, various coding languages actually use those programs as well as rules. As if-then, if this happens, then do this. If it is cold, start the heater. If it is um, let's say warm or hot, start the air conditioner. So these are those if-then rules, and all of these combined can be done uh, coding programming languages such as Lisp, list processing, and Prolog, programming in logic, Java, C++, C sharp, and so forth. We can use various, as I said, languages for doing that, and they keep on evolving. So the thing to remember is that you have various knowledge representations. The most common, as we will discuss later on in expert systems, are the if-then rules combined with facts. Okay, and that is what we will actually be using in addition to various others. I do not believe we have enough time in this program to do actual programming, writing physical code in languages, but we will show you how the rules are applied and how do you uh, manage them. Okay. Uh, in the case of rules being applied, what they do is you typically have control of the way the program works. Okay, control yourself. If this happens, do this. If this like a recipe flow chart, I'm sure you heard about this. Rules, on the other hand, in terms of flow chart as well, they are heuristic, meaning rules of thumb, and this is what you code. This is what you code in your uh, in your if then rules. Okay. And then you can convert formulas, algorithms in terms of rules as well. In the absence of incomplete knowledge, okay, you can actually define your own rules after you consult a medical expert or a software expert, and you can say, if this is the problem, then do this. If this, then do that, and so forth. I hope you have found this interesting. We will see you in the next video. Thank you very much.